Now that we have seen the algorithm and pseudocode for the exponential searching algorithm, let's try to implement it using Java. For that, I am going to go inside the searching folder or package. I'm going to create a new class called Exponential Search, and I'm going to add the main method also, and I'm going to click on finish. Now here let's define the exponential search function signature public static int exponential search, and it will basically take the integer array and the value that we want. Okay, now if you remember the pseudocode clearly, as part of the first step we'll have to find the range. So for that I'm going to define a variable called range, and I'm going to start it with index 1. Now as long as this range is less than the length of the array and the value at this range variable is less than value that user has given, we will need to move on to the next range. So we will simply update the range to range into 2. Okay, once we complete this range logic, right, whatever the variable range that we have here, it could contain the largest index or the maximum index at which the value could be present inside the array. So using this range we can find the range for the minimum and maximum for binary search. So how will we do it? Int min equal to, or the starting point for the binary search will be equal to range divided by 2. Why I am starting min with range divided by 2 is because before we go on to the largest index, that means prior to that we would have searched it, before multiplying by 2 we would have searched it divided by 2. That means whatever the value we have in the range variable we would have searched in previous one, which is nothing but range divided by 2. That means from there till array of length or whatever the range we got, there it could be present. So that's why I'm starting with the min value as range divided by 2. Now for max, or the end position for binary search will be math dot min of, we need to pass the range or the last index in the array, that is array dot length minus 1. Why I am trying to find the minimum value here is because we are multiplying by 2, right? Sometimes what could happen in few cases, whatever the range value, that could go beyond the length of the array. So if we try to search in the indexes that are not available inside the array, we will basically get the array index out of bounds exception, right? That's why I'm just trying to find the minimum value in the range and the last index inside that array. Okay, this is the min will represent the starting index in the binary search, and max will represent the largest or the ending position for binary search. Now all we have to do is, using these two we will have to call the binary search function. For that I'm going to go into this binary search implementation. I'm going to get this and just copy paste here. But if you remember the binary search implementation that we have done, right, here we are trying to perform the binary searching on the entire array. That's why the starting index or the min will be 0, the ending index or the max will be the largest index in the array. But here we have already calculated the min and max based on the range logic that we have here. So here we will not be starting from min and max based on the array, but rather based on the values that we have calculated. So I'm going to take them as a functional arguments. Now all we do is we will call the binary search function from exponential search function that we have written. This binary search function will anyway return the index or minus based on the value present in the array or not, right? So whatever that it is going to return, I'm simply returning that same value itself. Okay, so this is how we actually implement the exponential search. Now let's go and let's try to pass some values and see if it actually works. So integer array a equal to, let's say 1 2 3 4 5 6 7, because we need to pass the sorted values only to exponential searching and the value that I want to search is, let's say, 3. Okay, now let's just call the exponential search function, pass the array and value to it, and let's say int whatever the value that is exponential search is returning, let's try to capture inside this index variable and let's simply print it. Okay, let's say index. Now if I execute it, run as Java application, I got the output 2. At index 2 we have 3. Similarly, if I pass 7, I should get the output as 6 because index 6 contains the value 7. Okay. Similarly, if I pass the value, let's say 17, which is not available in the array, if I execute it, I got -1. Let's say I want to search the value 1 itself. Okay. Now run as Java application, I got the index 0. Similarly, if I pass the value, let's say -10, which is not available inside the array, if I run it, I should get -1 basically. Okay, I got the -1 in this case also. Okay, so this is how we actually implement the exponential searching algorithm using Java.